Hi, this is Havoc RC with another RC project. Have you ever wanted to control one of your RC planes by tilting a device? Well, today I'm going to do just that. We're going to export your phone's accelerometer data to an Arduino over a Bluetooth module. Utilizing our training port on the transmitter, we will connect our Arduino to the transmitter to act as a training radio, just like you would with a buddy box system. This project still heavily relies on the transmitter, as there is no rudder or throttle control. You only need a few components to complete this project. Those include a 3.5mm mono audio jack, an ftdi breakout board, an HC06 Bluetooth module, 2 LEDs, any Arduino, a power source for that Arduino, and a project box. In step 2, you'll need to download the tilttx.zip. This will contain the Amorino app, the Amorino toolkit, the Meet Android library, and a few Arduino sketches. First thing we need to do is install the Amorino app and the Amorino toolkit. This is what's going to export our phone's accelerometer data over Bluetooth. Once you have downloaded the Amorino app and toolkit, move them to your phone. Do not try to install them yet because we need to change a few things first. Since the Amorino app is not in the Google Play Store, it is considered an unknown source. Androids by default won't let you install unknown sources. So under security, checkmark unknown sources and hit OK. Unknown sources should now be checkmarked. Now you can open the amorino.apk and it'll install. Also install the Amorino toolkit and grant it any access it needs. Connect the HC06 Bluetooth module to the ftdi breakout board. RX on the Bluetooth module gets connected to the TX on the ftdi breakout board. The TX on the Bluetooth module gets connected to the RX on the ftdi breakout board. The VCC on the Bluetooth module gets connected to the 3.3 volts on the ftdi breakout board, and the grounds get connected together. Now just connect your ftdi breakout board to your computer. So the Bluetooth HC06 module comes pre-configured at a baud rate of 9600, and we need to change it to 115200 to work with our Meet Android library. So in order to do that, we're going to hook up our Bluetooth module to our ftdi breakout board, and then our ftdi breakout board to the computer, and then we're going to go to Tools, Port, and then select the correct port. Now open up the serial monitor, you don't have to worry anything about the code, and we're going to put this on 9600 and just type in AT, and you should get a response OK. If you don't get a response, try making sure that all your connections from your ftdi breakout board to your HC06 Bluetooth module are correct. If you get a response, that's awesome, but we need to change it to 115200 baud rate. So how you do that is you're going to type in AT plus baud 8. And then you see we'll get an OK back and then a 115200. And that means the Bluetooth module is now set at 115200. So in order to keep talking to it, we're going to have to change that to 115200 in our serial monitor. And if you type in AT again, you'll see we get a response. Now you can do several other things. You can type in AT plus name and so now we are ready to use our HC06 Bluetooth module with our project. Connect your HC06 to the Arduino as shown. With the HC06 still turned on, go to your Bluetooth settings on your phone. Select the name and type in the pin number 1234. Please note, the red LED on the Bluetooth module will not go solid after pairing with your phone. Now open the Amorino app, hit OK to the first screen that you get, and click on Add Bluetooth Device. The HC06 Bluetooth module should show up in here. If it does not, remove power to your HC06 Bluetooth module and restart your phone. Tell your phone to search for Bluetooth devices and power your Bluetooth module back up. Once it shows up in here, just tap on the name. Now tap on Connect. After you've connected, the red light on the Bluetooth module should go solid. Tap on the red box. There is no event selected, so click on Add Events, and we're going to add an accelerometer sensor. Make sure that it is on very fast and the data visualizer is on text. Hit Save. You should see numbers to the right of your accelerometer. If you don't, long press on accelerometer sensor and select Force Enable. Now you should see those numbers to the right. Now that we have our HC06 Bluetooth module connected to the Amorino app, and the Amorino app is sending accelerometer data, we can get started with the code. In my instructable, there is a tilttx.zip. If you download that, It'll have all of the files that you will be needing for this project, including the Amorino app and toolkit. So first we need to install the Meet Android library, and we're going to do that just by going to Arduino, Sketch, Include Library, Add Zip Library, and then navigating to the Meet Android folder. Select Choose, and simple as that. The library has now been installed with Arduino and we can start using it. We're going to open up the redraw Excel sketch. Go ahead and blow this up a little bit so you can see it better. And we're going to upload to the Arduino. Now make sure that your TX and RX wires are unplugged from your Arduino, otherwise it won't upload to the Arduino. You can't upload sketches to the Arduino while you have the TX and RX connected to something. So I'm going to upload this to my Arduino, and then I'm going to connect the TX and the RX. Now on my phone, I'm going to open the Amorino app, and then I'm going to connect to my Bluetooth device. And once I'm connected, I can go ahead and power my phone off and lay it with the camera facing to the left and the microphone facing to the right. And I'm going to open up the serial monitor, and boom, here's our data. Right here, this is our raw accelerometer data. And this is the same data, but it's just multiplied by 1,000. So what we're going to do is we're going to take our phone, and we're going to tilt it to the left, and take note of which number is moving. As you can see, the middle column here is increasing and decreasing when I move my phone. So we know that this middle number is roll. Now I'm going to tilt my phone backwards, and you can see that our first number here is increasing, and it's also decreasing. So now we know that that number is pitch. So now that we know which numbers represent roll and which ones represent pitch, we need to assign the variables roll and pitch to the correct index in this array. In order to do that, we need to know that arrays are 0 indexed, which means this element is index 0, this element is index 1, and this element is index 2. So for pitch, we know that this is index 0, and for roll, we know that it is index 1. So in our code, in section 2, we're going to change pitch to 0, and we're going to change roll to 1. Now we have the variable pitch assigned to index 0 in the array data. Same thing for roll. We have the variable roll assigned to index 1 of the array data. Now that we have pitch and roll corresponding to the correct numbers in our data array, we can get moving. Now let's get started by opening up the serial monitor. So what we can do is we're going to tilt our phone 45 degrees in one direction. And if you'll notice, about 5500 is on here, is about 45 degrees. And I don't want to go any further than this. So I know that I want my end point to be 5500 or negative 5500. And then I'm going to tilt it to the other direction, 45 degrees. And it's still 5500. And so I know that I want my input, my end to be negative 5500 to positive 5500. I'm going to do the same thing for the pitch. I'm going to tilt it backwards, 45 degrees, and I'm at 5500 again. I'm going to tilt it forward again, and I'm at 5500. So I know that my in and out points for pitch are also going to be negative 5500 to 5500. So we're going to go into the code and go ahead and change that. If you notice in section 4, there are 2 rows that you need to delete. So here are all the values already mapped out. For the pitch, I have negative 5500 to 5500, and then I'm remapping that to 1000 to 2000. And then same thing for roll, negative 5500 to 5500, mapping that to 1000 to 2000. Now, if you notice, I have these negative 12 and plus 7 here. This is just to bring the number as close as I can to the midpoint, which is 1500, which is between 1000 and 2000. So we can delete all of section 3 now and unplug our RX and TX wires from our Arduino and upload the sketch back to our Arduino. And then I'm going to plug the RX and TX from the Bluetooth module to the Arduino again. And I'm going to open up the serial monitor, and you can see that we have 1490 and 1489. Now that's not exactly 1500, which is the center, so we're going to go ahead and adjust those few numbers. Roll is at 1490. We need to add another 10 to it to get it to 1500. And notice that my phone is on a flat surface right now. And the same thing for pitch. It needs another 10 added to it to get it to 1500. So we'll go over here and roll. We needed to add another 10 to it, so I'm just going to make that 17. And pitch needed 10 added to it, so I'm going to delete that. So we have -2 and plus 17, and that should bring the numbers close to 1500. So I'm going to unplug my RX and TX again, upload the sketch to the Arduino, plug my RX and TX back in, go back to serial monitor, and there's nothing. Now this happens every once in a while. What happens is the amorino app stops sending data to the Bluetooth module. So we're going to go ahead and turn on disconnect from the Bluetooth module in our app, and we're going to reconnect. And there are numbers again. So now I'm going to lay my phone back down on a flat surface, and you can see that the numbers are very close to 1500, and that is exactly what we need. Now I'm going to tilt my phone to the left, and the roll should decrease all the way to 1000. It shouldn't go any more. It should stop at 1000. Now I'm going to tilt my phone all the way to the right, and it should increase to 2000 and no more. I'm going to point my phone backwards, and pitch should decrease to 1000, no more. And when I tilt it forward, it should increase to 2000 and no more. Now if you tilt your phone backwards and you notice that pitch is increasing rather than decreasing, then you need to change one small thing. All you have to do is go into your code under section 2, and where pitch is multiplied by 1000, change that to -1000. Unplug the TX from the Arduino, upload the sketch to the Arduino again. Then we're going to plug the TX back up and open our serial monitor, and we're going to try it out again, and you'll notice that pitch is now decreasing. Same thing for roll. If you tilt your phone to the left and you see that it's increasing instead of decreasing like it should, all you have to do is come in here and put a negative in front of that 1000. Now that we have our accelerometer data all mapped out, it is time to copy this code into our final sketch. So to do that, we're going to open the tilttx_final, and we're going to go back to redraw Excel, and you can see here this says page 1, and we're going to copy everything that's under page 1. Copy that, and then we're going to scroll down in our final sketch, and it says replace everything below with page 1. So we're going to take all of this and paste. And now we can unplug our RX and TX wires and upload this to our Arduino. And now we are ready to begin making the project. Since I lost all my Eagle CAD files, I couldn't make a nice schematic, so here's one that'll do. To begin this project, gather the following parts. I use an Altoids tin as my project box, but it's made out of metal, so I insulated it with some cardboard. I drilled 2 1/4-inch holes on the outside of the Altoids tin, and in the middle I made a hole big enough for my output cable to go through. This 500 mA 3S zippy compact fits perfectly in the back of the Altoids tin, so I slid that in. I'm going to be using the Arduino Nano because it's so small. The pins that we need to tin are VIN, ground, 5 volts, RX, TX, 6, 7, and 10. Cut and tin 4 jumper wires about 2 inches in length and connect them to RXD, TXD, GND, and VCC on the HC06 Bluetooth module. Now connect 5 volts from the Arduino Nano to the VCC on the Bluetooth module GND to GND, RX to TX, and TX to RX. Prepare the female JST connector. This will connect to the battery and provide power for the whole project. The black wire gets soldered to GND, and the red wire gets soldered to VIN. It is critical that the black and red wires coming from the JST connector do not touch. On the Bluetooth module, locate the status LED. We are going to unsolder this LED from the board and connect 2 jumper wires in its place. Now that the JST connector is soldered to the Arduino, plug in your battery and check to make sure that the Arduino powers up. Your Bluetooth module will also power up. Connect your multimeter to the 2 jumper wires we soldered onto the Bluetooth module earlier. If you're getting a negative voltage, switch the multimeter leads. The positive wire is indicated by the red multimeter lead. Mark this wire and unsolder the ground wire. We will not need it. Solder the positive wire from the status LED on the Bluetooth module to pin 7 on the Arduino. Find a long cable about 2 feet in length that has at least 2 inner wires. I used an old USB cable and cut off all but the red and black wires. I repeated this on the other side. Solder the red wire to the middle contact of the mono audio jack and solder the black wire to the ground connection. After you have done this, crimp down the little metal tab to hold the wire in place. After you've crimped the wire, you can slide the plastic case down the other end of the wire and screw it in place. Feed the open end of the wire through the hole you made in the middle of your Altoids tin and tie a stress relief knot. After you have tied off our output cable, solder the red wire to pin 10 on the Arduino and the black wire to ground. This step is optional, but it makes your project look a lot nicer. Press in 2 plastic LED holders into the 1/4 inch holes that we drew earlier and glue them down. Make sure you don't get any glue in the holes. The 2 LEDs were placed in their holders and the pins were bent as shown. Then I soldered them together and also soldered jumper wires to the positive and negatives of these LEDs. Connect the positive wire of the 2 LEDs to pin 6 on the Arduino, and the grounds go to ground. Then, using some hot glue, I glue the LEDs into their holders. Also, while I had my hot glue gun out, I made sure that the positive and negative wires were never going to touch. Now it is just a matter of organizing and gluing down parts. I added an extra piece of cardboard against the side wall to keep the pins on the top of the Arduino from shorting out. I originally was going to put a power switch on this project, but since this thing is going in my pocket, I don't want to be accidentally hitting that power switch and killing my control to my plane, so I just plug it in and unplug it. You should now be done with your project. Plug the wires up and close the lid. On your phone, open the Amorino app and connect to the Bluetooth. You'll notice that the LEDs will turn solid as soon as you're connected. We can now turn on our radio, plug in our mono plug into the training port in the back of our radio. Navigate to the trainer page on your radio and set the multiplier to 1.3. Lay your phone on a flat surface and calibrate. Now when you move your phone, you should be able to see the numbers moving. If you tried to build this and had any issues, head over to my Instructable and leave a comment in the box. I will get back with you as soon as I can. Thanks for watching this project. I hope you enjoyed it as much as I did. If you like this project, please subscribe to my YouTube channel and my Instructables page.